Okay, so I'm going to do an example based off of this lecture slide that I haven't seen in years. And the idea is here that I want to create, I think, just the idea that I had in my head is I'm going to create a couple of string buffers that I can then have different interfaces, and I'll show you the different ways that you would have users to interface with them. So the standard one is that you have some sort of like a public variable, so some sort of an extern variable that the user can just use like a normal variable. You can do whatever they want to it. So essentially, there's no error checking, and no sort of control from your side put on top of this variable. And then there's a private variable. We can do it in a few different ways. We can do a variable that's inside of an object that we return the object to them, and they can deal with the object. You can deal with a variable that's inside of an object and return to them as a handle. Or we can do a completely private object that's instantiated inside of the C file, and there's an only way to interact with it is through the header files and the C files. So I think there's sort of like these 4 ways of dealing with objects, and I'm going to do 4 separate little videos to talk about these, and I'll do one of them in this video, and that will be the standard extern variable, right? So to do a standard extern variable, this means that you create an extern definition of the variable in a header file somewhere, you instantiate it somewhere in a C file, and it's accessible everywhere in your project, right? As long as this header file with the external declaration of the variable is included. So I have here, I have a repository in my GitLab called C code snippets, and it's essentially just a repository full of random C code stuff. And so I've created in here a folder called OO_string, object oriented string, and you'll be able to find this code on there. Now, actually, what I might do is I might make this OO_string to OO_string1. And so we'll have 1, 2, 3, 4 for all of the different ones, right? So in here, I have a main, and in here I think there's just pretty much nothing, or some random stuff that I'll get rid of. This is, I think, from when I was doing the pointer stuff. I don't need my func either. And we can get rid of pretty much all of you. So I know this is a very bare minimum C project. Now I'm going to create in my includes string my string, just so it's not string.h, because that's a system header file. And then we'll make string.c. Ah, shit, this is not in source. So we'll move that to string into source. Right, okay, so now we'll go into source. We have our 2 files. Now I'm just going to quickly add my include guard to the header file. Now what this does is essentially it tries to avoid some sort of double circular inclusion. Sometimes it works with certain situations. But essentially all it's saying is if not def my string So it's saying if not defined, then continue pretty much. If this has already been defined somewhere, it doesn't need to be included again, sort of thing. And it's sort of, this is just good common practice to put something like this at the top of your header files. Usually a lot of IDEs automatically generate this for you. But if you're a text editor purist like me, you will have to write it in yourself. And then end if, and good practice to put a comment telling the person or whatever what if def you are ending, right? So now we have our header file, and now we want to do our public string. So we're going to go into our source file. No, we're already in there. So what did I call it? String. No, we need to make you move string to my string. My string. And so how a public, like an extern variable works is that in here we have a string, like a variable like a normal global variable, and we'll call this like my string, and this is a char pointer to a string called equals this is my string, right? So this is the variable, and now what we'll do is we'll go into our include, and we will create an external declaration of this variable. So we'll say extern, that was a mistake. Extern char pointer. It's the same thing, my string. And what you've done here is that here you've instantiated the object in the C file, as you can see up the top here. And down the bottom, we've created an external declaration of the variable, so that when this file, mystring.h, is included elsewhere, the file in which it was included is made aware that this variable exists. And so this is made as like a global, like project-wide. And so usually this is pretty risky to do. In multi-threading, this is pretty much a disaster. And so it should be used with utmost care. And this is probably the method I would least recommend you to use. But for completions or like for consistency, I will explain all the different methods, and this being one of them. So now we've created mystring.c with the variable in it and mystring.h with the declaration in it, an external declaration. So now what we can do is we can go to our main and we can include double little quotes because it's my thing. And so we'll go mystring.h. And so now essentially when this gets pre-processed, it's going to copy and paste this extern declaration of the variable that it exists. So we can use it. And what we can do then in here is we put a return 0 at the end because we're all good. Now we can say, we'll just do a really simple printf, print a string, and we'll put in, because it's called my string, we'll just put in my string. Okay, so now cmake to remove cmake cache, cmake. Where are you? CMake. Why are you being so annoying? Thank you. And we'll make this. And so we have implicit declaration of printf, which is, of course, this is my bad. We should have included the system header. stdio, standard input output, and we're using the square brackets for that because it's a system header. So now if we go and run make again, we got no errors. Cool. And now so if we run this, bin bar, I think this is what it's called, we'll see that it's just printed this is my string, which is exactly what we have defined here. And we can use my string because we've included this, and it's a public variable because of the extern definition. Now, what we could do, for instance, is we could just do a separate example with a char pointer. So say my dynamic string, and so we'll set this to null because it's a pointer to nothing yet, and we want to say we haven't allocated it yet. So sorry, I just can't type today. Dynamic string. And so then what we can do in our C files, we can use this and we'll actually allocate it. So we'll say my dynamic string equals malloc size of char times by, I don't know, what do we want to put in there? Let's just make it like, let's allocate 100 length. And then we can, or let's even calloc this so that it's zeroed out. So we'll say size of, we'll do 100. And so what calloc does is essentially it allocates the memory and then zeroes it out. And if we look at the man pages for it, we'll see that we have to call it by putting in the size of the member and then the length, right? Or then the number of the member, so n mem, and then this is the size of each member. And so I have 100 of size char, so 100 chars. So this is going to allocate me 100 bytes in memory that are all 0. Because it zeroes it out. So if we look here, calloc allocates memory for an array of n members, elements of size bytes each, and returns a pointer to the memory is set to 0. So this is very useful for when you're allocating structures and you want to make sure that everything in the structure is zeroed. Likewise, you could use malloc and then just use memset. But to make it easier, I love to use calloc. Calloc leads to, it has an overhead to it, but it generally leads to a more secure memory. through like trying to avoiding uninitialized memory errors. So now we've allocated this, and then we can go, we'll just go strcpy, string copy, and we'll put in, I can't remember which one comes first for string copy, destination comes first. So we're going to put this into my dynamic string, and we'll copy in, I wonder if I can put in a constant, if I can just do, this is my dynamic string, hopefully this will work. And then we can print this. So we'll print f, the same guy again. Oh, same exact line. My dynamic string. So hopefully I have not made a mistake here. I have null. Oh yes, because I'm missing in here. Include standard lib.h. There we go. And you'll see I have now, this is my dynamic string, and this is because I created an external pointer to a string, which I could then in my main allocate memory for and put some sort of content in, and then I printed it, right? And so this is a public function, a public variable that's stored in some other file that it can be accessed from everywhere, and it can be modified. Now what we could do is we could also create setters and getters in here, but this sort of avoids the point, like why have an external variable with a setter and a getter. So this is why I don't really ever use externs. On the rare occasion I use them as, for instance, in the TUM event where I wanted to literally just export the queue handle, because I know that there is an API to deal with the queue. You just need the handle. So now I'm going to stop this video there, and this is sort of like, I guess, the summary of how you use the extern keyword to create public variables. And now I will go in and talk about how you create sort of more object-orientated objects, where I mean a data structure with setter and getter functionality, which way you have like functions to work on the object. Okay, so I'll do that now.